Say, hey, hey now, baby. Oh, mama, don't play now.
My name is Nosuki, and today I'll be talking about the first part of Lab E5. So the first part is to explaining how the RTC is set up. So based on our code, we first initialize the function of RTC, which is initialize RTC. So first we initialize the clock using this code, and then moving on we enabling the registers. Then we switch off the status registers, and then we enable oscillator register, which is the CR, and then we clear the time invalid flag. And then moving on to this table, we can see that the registers, the first code, which is the enabling all the register LRL, SRL, CRL, and also TRL. This is to enable all the registers. So for the TCE, means that it is time counter enabled. We set it to 0 to allow writing into the TSR register, and for the OCCE, which means that we set the oscillator enable to 1 to enable the oscillator, and then for the TSR, which is the time. Okay, so for the TSR, which is the time second register, when the time counter is disabled, the TSR can be read or written, right? In our code, we write the TSR to 0, just so when the time counter is disabled, it will clear the time invalid flag. So for the time counter enable, for this part, when it is set to 0, when it is set to 1, sorry, TSR register and TPR register will then increment. And lastly, for the time second interrupt enable, we set it to 1 to generate edge sensitive interrupt once a second, so that no software overhead required. So other than this, we also have we also have two functions which enable the RTC interrupt and also disable the RTC interrupt, just so that the time will. So for the enable RTC seconds interrupt handler, we call the function enable interrupt into this function just to enable this interrupt. And for the disable RTC seconds interrupt handler, we call the disable interrupt function just to disable the RTC seconds interrupt. That is all for my part. Thank you.
I'll be showing you how we can set our time and date through our digital musical alarm clock here. So first we will enter the menu through the center button. So we have set times, set that, set alarm, and set tunes in our settings here. So first I would like to show you about our settings for our time. So it follows a 24-hour system, as we can see, 23 and 59. So this is how we can set it. The down button will increase value and the up button will decrease the value slowly. Same follows with the hours system. So now setting date. So we know that in the month of August we will have about 31 days. So setting to August. So we will expect 31 here. Then when you reach 31 days, it will jump to September the 1st. So we can see here 31 days, and it will jump to September here. And on September we know there are only 30 days. So expected when it reaches October, it will be straight jump to 1, as we can see here. So hence complements our date settings. And now moving on, we'll be talking about, we are testing for the end of the February to test for the leap year. So see, we have already preset the time to enter 29th of 2016, which is a leap year. See, so this is the alarm. So as we can see here, in the leap year we will have 29 days. So first, so to show that when it is on a different year, which is not a leap year, the expected date will be only 28, setting it to 28. So there won't be any 29 days in February, So as I push the up button and it will be entering the first day of March. Yep. So see, as you can see, there's no 29 days in 2017 because it's not a leap year. Hence complement our testing for the end of February, normal and leap year. So moving on, we'll be showing you and explain how to set the alarm time, enable and disable it. So moving on to the C program. So we'll be viewing it through our main C. So as you can see here, to test for the alarm, I've already preset the hours to 23 minutes 50 for the current time as we initiate it, and the alarm time will be 000. So in 10 seconds time, the alarm will be triggered. So moving back here, first I would like to show you through the SDA. First, we would like to debug the whole thing. Okay, run. So in 10-second time, the alarm will be triggered. So as you can see, the alarm is triggered. So to disable the alarm, we will be pressing the center button here. Let me show you. See, so the center button disables the alarm, so our test is correct for this part. And now I would like to show you how the music is generated. Moving on to the C program here. Our music is generated through a C program source file, which is residing in the lyrics C program here. As you can see, first, when the alarm is triggered, it will enter music one function, where first it will clear the LCD to our background color, and it will display the words as shown here through the LCD string. So all when the syncs all matching in, and to show that our lyrics is synchronized with the music tunes played, our lyrics is synchronized with the music tunes. For each note, we set their synchronized lyrics with it through this setting. And for the disabling part, we put if alarm trigger is equal to 0, which is set at the center switch, it will return from the music one, hence disabling the alarm. So now I would like to show you the additional features in our alarm clock. As you can see here, hold on a second. As you can see here, the additional features included is the ability to, additional feature to set the alarm tune, and in this additional feature, we also included another lyrics, which is the Twinkle Twinkle Little Star. Hence, I would like to complete my part, and that's all. Thank you.
Hello, I'm Melvin, and I will be demonstrating the last part of this lab. It's about the questions shown in here. For the first question is what is the controller doing most of the time? The value is initialized in the main, and when we start the system, it will show exactly like this. It will display the time in both analog and digital, and it will also show the date, month, year, and the day of the week, and also at the bottom will show the time that set for the alarm, and it will always remain like that as long as the button is not being pushed. For the another question, which is what is the system frequency of your system and how did you set it? For system frequency, we set it as 48 megahertz, and we set it in the clock.c, which as the constant. Moving on, for what does the system frequency affect your FTM mode? Due as this system frequency is used for us to generate the music note, which the calculation is shown here, as the
the frequency change, the frequency, the number of things that require for the knot will also be changed. Moving on, for what does the system frequency affect your RTC module, as the frequency is set as 48 MHz. In order for the system to function properly in RTC, you will need to have a 32.76 GHz clock cycle so that it can move smoothly. And I think that's all for me. Thank you.